It is indeed possible to supply both a dwelling unit and a retail space from a single electrical panel. The key consideration revolves around properly sizing the service and adhering to electrical codes such as the National Electrical Code, or NEC, and any local amendments in North Carolina. In the scenario you described, a 400 amp service can be utilized to feed both occupancies. The common approach is to split the 400 amp service into two separate 200 amps panels. One 200 amps panel will serve the dwelling unit, and the other 200 amps panel will serve the retail space. The NEC mandates that the panel serving the dwelling unit must be physically located within the dwelling unit. Similarly, the panel serving the retail space must be situated within the retail space itself. This separation of panels ensures that each occupancy has its own dedicated electrical distribution point. Now let's delve into some of the more technical aspects of this installation. Firstly, a crucial step is performing accurate load calculations for both the dwelling unit and the retail space. This involves determining the total electrical demand of each occupancy, considering factors like lighting, appliances, HVAC systems, and any other electrical equipment. The NEC provides guidelines and tables for calculating these loads, ensuring that the electrical service is adequately sized to handle the anticipated demand. It's important to use the appropriate demand factors specified in the NEC, which account for the fact that not all electrical loads will be operating simultaneously at their maximum rated power. Secondly, the selection of conductors and overcurrent protection devices, such as circuit breakers, is paramount. The conductors must be sized to carry the calculated load current, and the overcurrent protection devices must be selected to protect the conductors from overloads and short circuits. The NEC specifies the ampacity, which is the current carrying capacity, of different types of conductors based on their size, material, and insulation type. The overcurrent protection devices must have an interrupting rating sufficient to handle the available fault current at the service entrance. Thirdly, grounding and bonding are critical for electrical safety. The grounding system provides a path for fault current to return to the source, allowing the overcurrent protection devices to trip and de-energize the circuit. Bonding ensures that all metallic parts of the electrical system are at the same potential, reducing the risk of electric shock. The NEC outlines the requirements for grounding and bonding, including the size and type of grounding conductors and bonding jumpers. Fourthly, the installation of the service disconnect is an important consideration. The service disconnect is a device that allows the entire electrical service to be de-energized for maintenance or emergency purposes. The NEC requires that the service disconnect be readily accessible and located at a convenient point near the service entrance. The service disconnect must have a rating sufficient to interrupt the maximum available fault current. Fifthly, the wiring methods used for the installation must comply with the NEC. The NEC specifies the types of wiring methods that are permitted for different applications, such as conduit, cable, and raceway. The wiring methods must be installed in a neat and workmanlike manner, and they must be properly supported and secured. Sixthly, the installation must be inspected and approved by a qualified electrical inspector. The electrical inspector will verify that the installation complies with the NEC and any local amendments. The inspector will also perform tests to ensure that the electrical system is safe and functioning properly. Now let's address some potential challenges that may arise during the installation. Firstly, space constraints can be a major challenge, especially in existing buildings. It may be difficult to find adequate space to install the two 200 amps panels and the associated wiring. In such cases, it may be necessary to use compact panels or to reroute existing wiring to create more space. Secondly, coordination with other trades such as plumbers and HVAC contractors is essential. The electrical installation must be coordinated with the other trades to avoid conflicts and ensure that all systems are installed properly. Thirdly, ensuring proper separation between the dwelling unit and the retail space is crucial. This includes not only the separation of panels but also the separation of wiring and equipment. The NEC prohibits the use of common neutral conductors for multiple circuits serving different occupancies. Each occupancy must have its own dedicated neutral conductor. Fourthly, complying with accessibility requirements for people with disabilities is important. The NEC and the Americans with Disabilities Act, or ADA, specify requirements for the accessibility of electrical equipment, such as panel boards and receptacles. Fifthly, documenting the installation is essential. This includes creating accurate as-built drawings and maintaining records of all inspections and tests. The documentation will be helpful for future maintenance and troubleshooting. Let's discuss some specific NEC articles that are relevant to this installation. NEC Article 220 covers load calculations for buildings. NEC Article 230 covers service entrances. NEC Article 250 covers grounding and bonding. NEC Article 310 covers conductors for general wiring. NEC Article 408 covers panel boards. It is always recommended to consult with a qualified electrical engineer or electrician to ensure that the installation complies with all applicable codes and standards. They can perform a thorough load calculation, select the appropriate equipment, and ensure that the installation is safe and reliable. Furthermore, it's crucial to remember that electrical codes and regulations can vary depending on the specific location within North Carolina. Local jurisdictions may have amendments to the NEC or additional requirements that must be followed. Therefore, it's essential to check with the local building department or electrical inspector to determine the specific requirements for your area. Now, consider the scenario where the load calculation for the dwelling unit is significantly lower than 200 amps. In this case, it may be possible to use a smaller panel for the dwelling unit, such as a 125 amps or 150 amps panel. However, the panel must still be sized to handle the calculated load, and the conductors and overcurrent protection devices must be sized accordingly. Conversely, if the load calculation for the retail space exceeds 200 amps, it may be necessary to increase the size of the panel serving the retail space. In this case, it may be necessary to upgrade the service to a larger capacity, such as a 600 amp service. Another important consideration is the type of electrical service. There are several types of electrical services, such as single-phase, three-phase, and 120/240 volts, 208Y/120 volts, 480Y/277 volts. The type of service will depend on the size and type of electrical loads. It is always important to consult with the local utility company to determine the type of service that is available in your area. Furthermore, it's worth noting that some jurisdictions may have specific requirements for the separation of electrical services for different occupancies. For example, they may require that each occupancy have its own dedicated service entrance, even if the total load is less than 400 amps. This is often done to ensure that each occupancy has its own independent electrical system and to prevent interference between the two occupancies. In addition to the technical aspects of the installation, there are also some practical considerations to keep in mind. Firstly, it's important to choose a location for the panels that is easily accessible for maintenance and repairs. The panel should be located in a dry, well-ventilated area and should be protected from physical damage. Secondly, it's important to label all of the circuits in the panels clearly and accurately. This will make it easier to identify and troubleshoot problems in the future. Thirdly, it's important to provide adequate lighting in the area around the panels. This will make it easier to work on the panel safely and efficiently. Fourthly, it's important to keep the area around the panels clean and free of obstructions. This will prevent accidental damage to the panels and ensure that the panels are easily accessible. Fifthly, it's important to train the occupants of both the dwelling unit and the retail space on how to operate the electrical system safely. This includes teaching them how to turn off the power in an emergency and how to identify and report electrical hazards. Let's explore some additional scenarios and considerations. Imagine the retail space includes equipment with specific voltage requirements, such as 277 volts lighting. In this case, the panel serving the retail space might need to be a three-phase panel to accommodate these voltage requirements. The dwelling unit typically uses a single-phase 120/240 volt system. However, The three-phase panel introduces additional complexities in the wiring and overcurrent protection, requiring careful planning and execution. In another scenario, the retail space might include a commercial kitchen with heavy-duty appliances. These appliances often require dedicated circuits and may draw significant amounts of power. The load calculation for the retail space would need to account for these appliances, and the panel and service must be sized accordingly. It's also crucial to consider the potential for future expansion. If either the dwelling unit or the retail space is likely to expand in the future, it's wise to size the panel and service with some extra capacity to accommodate the increased load. This can save time and money in the long run by avoiding the need for costly upgrades later on. Another important factor is the coordination of overcurrent protection devices. The circuit breakers in the panel should be selectively coordinated to ensure that only the affected circuit trips in the event of a fault. Selective coordination minimizes the disruption to other circuits and improves the reliability of the electrical system. Selective coordination requires careful selection and coordination of the circuit breaker trip curves. Consider the impact of energy efficiency measures. Implementing energy-efficient lighting, appliances, and HVAC systems can significantly reduce the electrical load of both the dwelling unit and the retail space. This can potentially allow for a smaller service size and lower operating costs. However, it's important to factor in the potential for future upgrades to less efficient equipment when calculating the load. Furthermore, it's essential to ensure that all electrical work is performed by qualified and licensed electricians. Electrical work can be dangerous, and it's important to have the work done by someone who is trained and experienced. Licensed electricians are familiar with the NEC and local codes and can ensure that the installation is safe and compliant. Finally, it's important to remember that electrical systems require regular maintenance. This includes inspecting the panels, tightening connections, and testing the overcurrent protection devices. Regular maintenance can help to prevent problems and extend the life of the electrical system. It's recommended to have the electrical system inspected by a qualified electrician at least once a year. Remember to keep safety as the utmost priority when dealing with electrical systems. Always to energize the circuit before working on it and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working on electrical systems, it's best to call a qualified electrician. By following these guidelines and consulting with qualified professionals, you can ensure that the electrical installation is safe, reliable, and compliant with all applicable codes and standards. This will provide a safe and efficient electrical system for both the dwelling unit and the retail space. And always remember, when in doubt, consult with a qualified electrical professional. Their expertise can help ensure a safe and code-compliant installation. They can provide guidance on load calculations, equipment selection, and wiring methods. Engaging a professional is an investment in the safety and reliability of the electrical system. Keep in mind, local amendments to the NEC might introduce specific requirements related to surge protection. For instance, some jurisdictions mandate surge protection devices, or SPDs, at the service entrance to safeguard against voltage spikes caused by lightning strikes or utility grid disturbances. The SPD diverts excess voltage away from sensitive electronic equipment, preventing damage. When installing SPD, ensure they comply with UL 1449 standards and have an appropriate surge current rating for the anticipated surge levels in your area. The selection of the appropriate SPD depends on factors such as the service voltage, available fault current, and the sensitivity of the connected equipment. Additionally, consider the coordination of SPD throughout the electrical system to provide comprehensive surge protection. It is a good idea to incorporate arc fault circuit interrupters, or size, and ground fault circuit interrupters, or GFCIs, for enhanced safety. ASIs are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. ASIs are typically required in dwelling unit branch circuits that supply receptacles, lighting, and other loads. GFCIs are designed to protect against ground faults, which can cause electric shock. GFCIs are typically required in wet locations such as bathrooms, kitchens, and outdoor areas. When installing FSIs and GFCIs, ensure they are properly tested and maintained to ensure they are functioning correctly. Moreover, it's beneficial to integrate smart home technologies into the electrical system. Smart home technologies can provide enhanced control, monitoring, and energy efficiency. For example, smart lighting systems can automatically adjust the lighting levels based on occupancy and ambient light levels. Smart thermostats can optimize heating and cooling schedules to reduce energy consumption. Smart plugs can be used to remotely control appliances and devices. When integrating smart home technologies, ensure they are compatible with the existing electrical system and comply with all applicable codes and standards. Also, consider the security implications of smart home technologies and take steps to protect the system from unauthorized access. Remember that electrical systems are not static. They evolve over time as new technologies are introduced and building codes are updated. Therefore, it's essential to stay informed about the latest developments in the electrical industry and to periodically review the electrical system to ensure it remains safe, efficient, and compliant. Consider attending industry conferences, reading trade publications, and consulting with electrical professionals to stay up to date. This proactive approach can help identify potential problems before they become serious and ensure the electrical system continues to meet the evolving needs of the occupants. Keep in mind that the electrical system is a critical component of any building, and its safety and reliability are paramount. By following these guidelines and working with qualified professionals, you can ensure the electrical system is well designed, properly installed, and adequately maintained. This will provide a safe and comfortable environment for both the dwelling unit and the retail space, and it will help protect the building from electrical hazards.